Yeah, as Tom already said, I'm very sorry that Delphine could not come today, so therefore I present her research now at the beginning. And this was a joint activity together with Gang. He is sitting over here, so you can discuss also with him afterwards. And this represents a typical case of a workflow. So we have some data, we have some new data developed, and we want to know about the impact of these new data on certain aspects, and one of those is how the crop yield projected by global crop models could change when we introduce new data on irrigation in India. Which one is?
Try the arrow.
The other one? Ah, okay. Thanks. Yeah, the study setup is shown here. There is the region in which the study is focusing is India. We have 3 crops: maize, soybean, and wheat, and different climate scenarios from 5 different GCMs. And then we focus on the results of the Pegasus model, but in addition we also were running 3 other models to have a look on the differences between models itself. And then we were using different data about the crop coverage, so which crop is grown where and whether it is irrigated or not. And about this irrigation data, I want to show some more details. So we had basically 3 different products. One is the Merca 2000 data set, which was mentioned already, which is built a lot on Naveen's research. And the base here for the underlying data is more year 2000. And then we have a new product which is mainly based on national data for India. This is then this one, and the resolution also of statistical information is changing from state level to district level, so higher resolution of the underlying data. And then we have a third data set which is simplified. So here we combine just our global map of irrigated land with the cropland map and compute for each pixel the percentage of cropland that is irrigated, and then we assume that each crop is irrigated with the same ratio. So at the pixel level, no difference between crops. So this is the major difference. With regard to harvested area, the differences in the 2 data sets are not that large, so we see some differences here, in particular for soybean, for example. So the patterns look a bit different, but not so much. So it means that the Earth stud data used for year 2000 still represent quite well the pattern that we find today. Oh, sorry, this was the wrong one. Yeah, with regard to irrigated land, it's a bit different. So we see here, for example, for soybean, large differences. So when we assume that soybean is irrigated with the same fraction than all the other crops, then we have a lot of irrigated soybean area here in the center of India. But if we use the reported data for irrigation of soybean in India, it looks quite different. And we also see some differences here for maize or for wheat in this region. So which result does, or which impact does this have now on simulated yields? Or first of all, I also want to briefly show some differences on the state level in India. So we can see again here that the differences in harvested land are not that much. So the crop data are still quite representative. Even the year 2000 data but with regard to irrigation, there are big differences across the states in India. And this can also be seen from the other, or for the other crops. So this is wheat, and this is soybean. So soybean is not cultivated that much at the moment in India, but the area is growing, so it might be important because of this. And so let's now look at the impact of these different data on simulated yields under climate change. First let's have a look on the 2020s. So this is the difference in crop yield simulated by Pegasus for the different crops with the different data. And as we can see, there are some differences, in particular for soybean, mainly in this marginal cropping areas for this crop. But more or less, the pattern is quite consistent. Here there are some differences for maize, but for us it was quite surprising that the difference was not larger. So I have still some problems with this device. So, okay, let's switch to the 2050s. The impact simulated with Pegasus is, of course, much larger for this period. So, according to this model, there is a sharp decline in yields for all the three crops, while the differences introduced by the different data sets are still relatively small, and mainly in these marginal cropping regions, which we already have seen before. When we then zoom up the production at the federal state level, we also see not some differences, but they are still quite moderate. And this is, for example, for maize. So we see in the major growing areas some differences of, let us say, 5 or 10%. More interesting or more striking was the difference between models. I mean, that's quite common. There's a lot of discussion. As you can see here, the results for 4 different crop models, the models differ with regard to several aspects. And the Pegasus model, the results I have shown before, has some speciality that it's also sensitive to heat stress, for example, and that is also simulating the growing period, so changes in the growing period due to climate change. And so what you can see here are big differences across models, but the data, the irrigation data, the different data sets introduced to these models have, let us say, moderate impact, which was a bit surprising to us. And of course, first of all, I would like to summarize the outcomes. So we can see that we have in particular differences in the marginal cropping regions, and as you can see here, so when we sort these changes or uncertainties, then the crop modeling part is still on top, and then the climate input and the irrigation and crop data. And now we were asking, why is this the case? So can we just therefore stop improving the data on irrigated land? And I think we shouldn't do this. This study was focusing on changes in yield under climate change scenarios, and of course, you know the resolution of the global climate models is limited. So it means we have a coarse resolution climate change signal, and then and then we have the irrigation data, which have now much higher resolution, and this, of course, that does not fit. Or it could be that the improvement or the change from state to district level information is just not showing up because of this mismatch in the resolution. And another reason is we have still problems with the global crop models to simulate realistic cropping seasons. This is very difficult to simulate crop phenology, in particular at the global scale. And I also would like to show one example here from Pegasus. For example, here we see the simulated or the sowing date used in Pegasus for the 3 different crops. So we have here the day of the year, and this is from 1st of January to end of the year. So this is what goes into the model, and this is what national data or publications report with regard to the growing seasons of the crops. And I mean, we have a problem for wheat. This is known because in Pegasus mainly spring wheat is simulated, while in India wheat is grown in the winter season. But also for maize we see some differences, and we have here 2 growing periods in the year, and this of course does not really fit to the assumptions made in the model. Sorry. Yeah, and this can have of course an impact, because when you simulate wheat in the hot summer season with a model which introduces the effects of heat stress, then it's clear that this will have a large impact on the model result, and that at least some of the differences between models can be explained because of this assumptions or data going into the model. Yeah, this is Delphine's contact address. If you want to discuss this further with her, please send a message.